Hi, this is Mrs. Ramirez. This is our first of many videos on advanced algebra, and I'm looking forward to spending the year with you through these videos and through our class time together. Our first lesson today is lesson 1.1, and it's called the language of algebra. We're going to talk about a few vocab words in this lesson, the first one being an algebraic expression. Hopefully this is a review for everyone. An algebraic expression is an expression that has numbers or numbers and variables. It does not have an equal sign. And an algebraic sentence is an expression with an equal sign or an equality sign. If you look at this blue box right here, these are any of the signs that could be in an algebraic sentence, and that is your big clue. If you see any of these in an expression, then it makes it a sentence. If you look at these two examples right here, a equals the square root, or a equals s squared times the square root of 3 divided by 4. And v equals 1/3 pi r squared height. So your area and your volume, those are both algebraic sentences because they have the equal sign in them. So we're going to talk about writing or practice writing expressions and sentences. In this first example, Joseph has a collection of 1,380 comic books and buys 17 new titles every month. If Joseph continues collecting comic books in this way, how many comic books will he have after m months? Well, let's write this algebraic expression. So he has 1,380 comic books already, and he's going to buy 17 more every month. So we're going to say 17 times m, where m equals months. That would be an algebraic expression right there. For example 1b, Maria is collecting stamps. She already has 860 stamps in her collection, so she has 860. And she plans to buy 20 more stamps each month. So she's going to buy 20 each month, where m also equals months. How many stamps is Maria going to have after a certain amount of months? This would be the algebraic expression that would show that. We also have rules in order to evaluate these expressions. When you evaluate the expression, what you do is you substitute numbers in for the variables in that expression, or like an expression we just wrote, and then you calculate the results and calculate results. So you substitute numbers in for the variables and you calculate the results. Remember, we have to follow the rules for the order of operations. This is very important. We do parentheses or other grouping symbols from the innermost group out. And within grouping symbols, if there are no grouping symbols, we go from left to right. So we go from left to right. And we multiply and divide from left to right, add and subtract from left to right, and take powers from left to right. So we have to remember our order of operations. Let's work through a few examples for this. We're going to, example 2a, find the value of negative b minus the square root of b squared minus 4ac all over 2a. And you should recognize that formula. We're going to substitute in the following into that. In this case, it's actually an expression because there's no equal sign. So we're going to say negative, and we say b equals -1, so we're going to put -1 in for that. And here we go, we have another b squared, so we're going to put a -1 squared minus 4, and they say a is 3 and c is -4. Make sure this is written properly, and then you have 2 times 3 on the bottom because 3 is for A. So now let's simplify that. A negative times a negative 1 would be 1 minus the square root of negative 1 squared would be 1 minus, you have 4 times 3 times negative 4, which would be negative 64. Or negative 48, I'm sorry. Negative 48. We still have that square root. All over 2 times 3 is 6. We simplify it some more. We have 1 minus the square root of 1 minus a negative 48, which would be 1 plus 48, which would be 49, all over 6. 1 minus the square root of 49 is 7 over 6. You have 1 minus 7 is negative 6 over 6, which equals negative 1. Example 2b. Here is your expression for this one, and they say substitute in the following into it. So a equals 5. So let's write this and substitute in. So 2 times 5 squared minus, and they say c is 4 squared, plus c is 4, plus b squared is 6 squared minus 5 squared plus 4 squared. We'll simplify that some more. 2 times 5 squared is 25 minus 4 squared is 16, so that's 9 plus 4 plus 6 squared is 36 minus 25 plus 16. 2 times the square root of 9, the square root of 9 is 3, so 2 times 3 is 6, plus 4, plus 36 minus 25 plus 16 is square root of 27, because 36 minus 25 is 11, plus 16 is 27. We can simplify that more. 6 plus 4 is 10, plus 3 times the square root of 3. Which is the same as the square root of 27. Okay, next we're going to talk about an equation and a formula. An equation, it's a sentence stating that two expressions are equal. So a sentence stating that two expressions are equal. So if that's an equation, then a formula is just an equation stating that a single variable is equal to an expression with one or more different variables on the other side. So let's write that out. So a formula, we said, was an equation that says that a single variable, so you have a one variable on one side of that equal sign, and that is all equal to an expression with one or more different variables on the other side. Okay, let's write some examples for that. So an example of an equation would be x equals 15. It just says that two expressions are equal. One expression is x, another is 15, they're equal. An example of a formula would be y equals 3x plus 4. And this is a formula because you have a single variable on one side of that equal sign, and then you have an expression with one or more different variables on the other side. So there's a variable of x that's different from the y. So that's a formula. Another example of a formula would be area equals pi r squared. Here is your single variable on one side, and you have one or more different variables on the other side. Both of these I want you to notice that are also equations as well, because it's a sentence stating that two expressions are equal. So this one's an equation and a formula. This one's an equation and a formula. However, this first one that I wrote was only an equation, not a formula. Let's do two examples working with what we just talked about. Okay, that first example, example 3a. A kilowatt hour is 1 kilowatt of power used for 1 hour. What does it cost to have a 60-watt bulb turned on for 33 hours at a cost of 9.53 cents per kilowatt hour? Well, we can determine that cost is going to equal that 60 watts times the number of hours, 33 hours in this case, times the cost per hour. And that's 9.53 cents per kilowatt hour. And the key here is notice we have kilowatts and we have watts. Those don't match up, so we got to fix it. We got to change that 60 watts to kilowatts. We know that there is 1 kilowatt in 1,000 watts, and we're going to multiply that by 60 watts. Those, we can say it's over 1 if that helps. We can cancel out those watts, so we know we're going to be left with kilowatts. We have 60 over 1,000. 60 divided by 1,000 is 0.06 kilowatts. That's how many kilowatts. So a 60-watt bulb is also known as 0.06 kilowatt bulb. We just never call it that. Okay, so now we can go back to our cost formula, and we can say cost equals 0.06 kilowatts times 33 hours times 9.53 cents per kilowatt hour. And if we multiply, or if we cancel out, we know our kilowatts are going to cancel out, our hours are going to cancel out. We're left with cost equals 0.06 times 33 times 9.53 cents. That's our only unit left, so we know that's what our units are going to be for this. If we multiply that all through, we're going to have 18.87 cents. That's what it costs to have a 60-watt bulb turned on for 33 hours at a cost of 9.53 cents per kilowatt hour. We can give a formula for the cost in terms of the three numbers in the problems. The three numbers being the watts, the hours, and the cost are the cents per kilowatt hour. So we can say cost equals the watts we know as power, so we're going to use P, times time, which was hours, times that unit cost of 9.53 cents per hour. So we say P equals watts, in this case kilowatts, T equals time, in this case months, or hours, I'm sorry, hours, and U equals that unit cost. In this case, it's going to be cents per kilowatt hour. Okay, work through the second problem and see if you can figure this one out. I'll start it out for you. It's going to be the same as example 3a. So cost equals number of watts. So this time we have 15 watts times the number of hours, and it's 33 hours again, times that same unit cost of 9.53 cents per kilowatt hour. See what you get for cost. Remember your conversion, just like up above. You have to convert from watts to kilowatts. So what they want to know is a 15-watt energy-saving spiral bulb produces the same amount of brightness as a regular 60-watt bulb. What does it cost to have a 15-watt bulb turned on for 33 hours at 9.53 cents per kilowatt hours? So we're talking now about those more energy-efficient light bulbs. So are they going to be any cheaper? Hopefully they are, because that would be the whole point of using them. So see what you get. Your final answer on this one should be 4.72 cents. So they are cheaper.